Last week, a report leaked that Google is quietly building a chip. Internally, they're calling it Frozen, and the real story behind that name is far stranger than it sounds. Every headline about it uses the word frozen. Your brain jumps straight to liquid nitrogen, cryostats, some quantum refrigerator humming away in a sub zero lab. That is not what's happening here. Nothing about this chip is cold. Here's what actually happened. The information reported that Google is developing a new server chip, internally called Frozen V2, built to run its Gemini models far more efficiently. Alphabet's stock moved within hours of the story breaking, closing up over 3% on a chip that isn't even finished yet. That's not a small reaction. That's Wall Street pricing in a bet on silicon nobody outside Google has actually seen. Why would a company bet billions on something that doesn't exist? You are watching the Tech Tales. Take a second, hit subscribe, and let's get into it. To understand why investors care, you need to understand what a normal chip does every time you send Gemini a message. It loads the model, it fetches the weights, it computes, then it fetches again and again. Consider this fact. Shuttling data between memory and the processor costs roughly two orders of magnitude more energy than the actual math. Engineers have a name for this. They call it the memory wall, and it's been haunting computer architecture since the 1940s. This isn't the first time Google has hardwired its way out of that problem. Back in 2013, Google's own engineers ran a calculation that should terrify anyone in infrastructure. If Android users adopted voice search the way the company expected, using it for just 3 minutes a day, they'd need to double their entire global data center footprint just for search. So, where do you even find a solution to a problem that big? Google went digging into an old idea. In 1978, two researchers at Carnegie Mellon, named H.T. Kung and Charles Liserson, published a paper called Systolic Arrays for VLSI. Named after the pulse of a heartbeat, the design let data enter a chip once and flow through a grid of multipliers without ever going back for more. Nobody used it commercially for almost 40 years. Then, Jeff Dean, Google's chief scientist, recruited a hardware architect named Norman Juppy, and together their team built it into silicon. That chip shipped quietly in 2015. It became the Tensor Processing Unit. That was step one. Build a chip for AI math in general. Frozen V2 is Google trying something stranger. Not a chip for AI, a chip for one specific AI. Here's the fact that actually matters. Frozen V2 doesn't freeze Gemini's answers, it freezes Gemini's shape. The blueprint of the neural network gets etched directly into the silicon, while the model's learned parameters, the weights, can still be swapped in and out with every new release. But here's the twist most coverage buried. The original version of this project was far more extreme, and it also came from Jeff Dean. His first proposal wanted to burn Gemini's actual trained weights straight into the chip, not just the architecture. Google killed that version. Why? Because a chip built around one exact set of weights becomes e waste the moment the next model update ships. Frozen V2 is the compromise. Freeze the shape, not the soul. So, what's the actual payoff for playing it safer? Engineers on the project estimate Frozen V2 could serve 6 to 10 times more tokens per unit of power than Google's newest TPUs. That's not a refresh cycle. That's a different category of chip. And here's what's happening beneath that number. Google is spending somewhere between 180 and 190 billion dollars this year alone on AI infrastructure. It still isn't enough. The shortage got so severe that Google Cloud reportedly had to turn away paying customers. Frozen V2 isn't a moonshot, it's triage. Google isn't alone in this either. OpenAI just shipped its first custom chip with Broadcom called Jalapeno, designed and taped out in 9 months. Anthropic is reportedly working its own silicon deal with Samsung. Every major AI lab on Earth is racing toward the same trade: give up flexibility, buy back speed. But freezing anything is a bet that the shape underneath it won't need to change. What happens if Gemini's underlying architecture gets replaced before the chip even ships? Frozen V2 doesn't become efficient. it becomes the most expensive paperweight in Mountain View. What are your thoughts on Frozen V2? Subscribe and see you in the next one.